Good day, everyone. It's another learning episode from your teacher Marlene, and our today's episode is about the division of radicals. Some of the prerequisite topics in the division of radicals are the following: the law of exponent for quotient, rationalizing denominator, and using conjugate of denominator. So before you proceed, try to recall these topics because this will be useful in our discussion. Now let me show you how to find the quotient of the following examples. For number 1 example, the given is the square root of 8a cubed divided by 2a. So looking at the radicand, we can divide 8 by 2, which is 4, and a cubed divided by a is a squared. So we can simplify it to the square root of 4a squared. And the square root of 4a squared is equal to 2a, which is our quotient. So using this example, let me remind you that if we can divide the radicand, try to divide it first. Let us have more example. For number 2, the given is the cube root of 32n raised to 8 is divided by 4n squared. So similar to the first example, we can divide the radicand 32 divided by 4, which is 8, n raised to 8 divided by n squared is n raised to 6. So we can get the cube root of 8n raised to 6. Observe that 8n raised to 6 is a perfect cube, so we can get 2n squared. That's our quotient. Now let us look at example number 3. The given is the square root of 64a cubed b raised to 7 divided by 8a b raised to 4. Again, let us divide them one by one. 64 divided by 8 is 8. A cubed divided by a is a squared. And b raised to 7 divided by b raised to 4 is b cubed. So we applied the law of exponent for quotient. So at this point, we arrive at the square root of 8a squared b cubed. The quotient is not yet in simplest form, so let us separate the factors to perfect and not perfect square. So we have the square root of 4a squared b squared, which is the perfect square, times the square root of 2b, which is not a perfect square. Then getting the square root of 4a squared b squared, we will get 2ab. And let us copy the square root of 2b. And this is the simplest form of the quotient. Let me show you another example. So we have 10 square root of 8a raised to 7 b raised to 6 is divided by 2 times the square root of 2ab. So let me show you the detailed solution. Let us start with the coefficients. 10 divided by 2. Then the radicands, 8 divided by 2. Then applying the law of exponent for quotients by subtracting the exponents. So a raised to 7 minus 1, b raised to 6 minus 1. Then let us simplify this. 10 divided by 2 is 5. Then under the radical sign, we have 8 divided by 2 is 4. A raised to 7 minus 1 is a raised to 6. Then b raised to 6 minus 1 is b raised to 5. Now the result is not yet in the simplest form because looking now at the exponents, they are more than the index. So we have to separate the perfect to not perfect square. So our perfect square is 4a raised to 6 b raised to 4. And the not perfect square is the square root of b. So getting the square root of 4a raised to 6 b raised to 4, which is 2a cubed b squared. Then multiply this to 5, we will get 10a cubed b squared. And let us copy the square root of b. So this is the result. Now this time, let me show you how to divide radicals using rationalizing denominator. For example number 5, we have 4x over cube root of 2x. So looking at the denominator, the index is 3, but the exponents are both 1 for 2 and x. So we will multiply this to the cube root of 2 squared x squared over cube root of 2 squared x squared. This process, we can rationalize our denominator. So multiplying the numerators, 4x times the cube root of 2 squared x squared will give us 4x cube root of 4x squared. And the product of the denominators, cube root of 2x times cube root of 2 squared x squared is cube root of 2 cube x cubed, where it can be simplified to 2x. Observe that we can cancel 4x with 2x, so that the result will be 2 cube root of 4x squared. This is the simplest form of the quotient. Now let me give you another example. For number 6, our given is the square root of 2xy divided by 6x. Observe that there is common between the numerator and denominator, so that we can divide them by 2x. So 2x divided by 2x is 1. And 6x divided by 2x is 3. So we arrive at the square root of y over 3. And to rationalize, let us multiply this to the square root of 3 over the square root of 3. And we will get, for the numerator, y times the square root of 3 is the square root of 3y. And the square root of 3 times the square root of 3 in the denominators, we have the square root of 9. So separating them, we will get the square root of 3y over the square root of 9, and the square root of 9 is equal to 3. So this is the simplest form. Now, since I explained the process in dividing radicals using one term, let me give you another form of dividend. For number 7, our given is 8 square root of 12 minus 6 square root of 6 plus 4 square root of 96 are all divided by 2 square root of 3. This means that all terms in the numerator are to be divided one by one in the given denominator. So 8 square root of 12 divided by 2 square root of 3 minus the second term, 6 square root of 6 divided by 2 square root of 3 plus the last term, 4 square root of 96 divided by 2 square root of 3. Let us simplify the first term. 8 divided by 2 is 4, and the square root of 12 divided by the square root of 3 is the square root of 4, where the square root of 4 is equal to 2, and multiply 4 and 2 will give us 8. Similar process in the second term. Negative 6 divided by 2 is negative 3, and the square root of 6 divided by the square root of 3 is the square root of 2. So we have negative 3 square root of 2. And let us copy this to align in the first term. Now for the last term, let us simplify this. 4 divided by 2 is 2, and the square root of 96 divided by the square root of 3 is the square root of 32. Now since square root of 32 is factorable to perfect square, which is 10, and non-perfect square, which is the square root of 2. Now, let us get the square root of 16, which is 4. Okay, let us continue on this part. So, multiplying 2 and 4, we will get 8. And the result is 8 minus 3 square root of 2 plus 8 the square root of 2. So, looking now at the last two terms, they are called similar terms. So, combining negative 3 square root of 2 plus 8 square root of 2 will result to 5 square root of 2. So, this will be our final answer. Now, on the next example that I am going to show you is the application of the conjugate. Have you remembered that in our multiplication of radicals? So, for our example number 8, our given is the square root of x minus the square root of y is divided to square root of x plus the square root of y. So, if the binomial is observed in the denominator, try to look for its conjugate. That is the opposite sign in between them. So, since we have the square root of x plus the square root of y in the denominator, its conjugate is square root of x minus square root of y. So, multiplying this to square root of x minus square root of y over square root of x minus square root of y. Now, looking now at the numerators, we are multiplying square root of x minus square root of y times square root of x minus square root of y. It is the same as the square of binomial. So, if we're going to square the square of square root of x, that is square root of x squared. And then, 2 times the product of the first and the last term. So, we have negative 2 times the square root of xy. And the square of the last term, which is the square root of y. So, we have the square root of y squared. Now, looking now at the denominator, observe that they are sum and difference. So, using the special product, let us get the square of the square root of x minus the square of the square root of y. So, simplifying this, we have x minus 2 square root of xy plus y over the simplified form of the denominator x minus y. So, this is our final answer. Let us practice the process of using conjugate using our example number 9, where our given is the square root of 3a minus the square root of 2b is divided to the square root of 3a plus the square root of 2b. Can you give the conjugate? Yes, it is the square root of 3a minus the square root of 2b. So, to simplify, let us rationalize this using the conjugate. So, multiply to the square root of 3a minus the square root of 2b over the square root of 3a minus the square root of 2b. So, applying the square of binomials in the numerator and the sum and difference of binomials in the denominator, we will get, so the square of the first term, the square root of 3a plus 2 times the product of the first term, the square root of 3a times the second term, negative the square root of 2b, then added to the square of the second term, the square root of 2b, wherein in the denominator, we have to square the first term, the square of the square root of 3a minus the square of the square root of 2b. So, simplifying this, we will get 3a minus 2 square root of 6ab plus 2b all over 3a minus 2b. And this is our result. Now, similar to multiplication, The quotient is possible if the given indices are similar. But in our next example, observe that they are of different indices. We have the square root of 18 plus the square root of 8 is divided by the cube root of 2. Let us simplify the numerators. We have the square root of 18 is factored into square root of 9 times the square root of 2. And the square root of 8 is factored into square root of 4 times the square root of 2. So getting the perfect square, we will arrive at 3 square root of 2 plus 2 square root of 2. Observe that these are similar radicals so that we can combine this into 5 square root of 2 and is divided to cube root of 2. Now, since we cannot divide them because the indices are different, let us change this into rational form. So 5 times 2 raised to 1/2 over 2 is raised to 1/3. So getting the LCM, which is 6, 1/2 is equal to 3/6, and 1/3 is equal to 2/6. Then changing this to radical form, we have 5 times 6th root of 2 cubed is divided to 6th root of 2 squared. Now we can divide the radical using the log exponent for quotient, where 2 is raised to 3 minus 2, which is 1. So we have 5 times the 6th root of 2 as the final answer. That's all about division of radicals. I hope you see and follow in these examples so that you can be ready in answering your test. So for today's food for thought, mankind should always stay united, standing shoulder to shoulder, so evil can never cheat and divide them. This is by Susie Kaysem. Thank you for watching. Don't forget to subscribe and share to others so that you are spreading the learning. God bless everyone.